All right, so the next session is on the network re-architecture. Also have called this NetVirt evolution, and some work that I've been looking at together with Sam, Vishal, and Anil. And it's looking at taking, expanding the NetVirt functionality. So currently, the OVSDB NetVirt project includes really two components. One is the OVSDB southbound that implements the OVSDB protocol, various OVSDB schemas, and the NetVirt network virtualization solution that currently is supporting the OpenStack networking. So currently the NetVirt it's a fairly monolithic design. It's focused on supporting OpenStack, the Neutron API, on the northbound side, and OVS switches on the southbound side. And the goals of the work that we're doing here is to kind of break that up, make it allow, first of all, to support NetVirt as a separate application. Right now it's an integrated project. There are kind of different layers of the overall model, and we're looking at separating that NetVirt functionality out, but also to make NetVirt more scalable, modular, and extensible. And one of the things that I just on this slide wanted to point out was that this NetVirt currently uses interfaces with the Neutron northbound via MD-SAL, and via the two southbound protocols, it's using both OVSDB and OpenFlow to control these OVS switches. We've been working on, in this past release, the addition of the layer 2 gateway support using the hardware VTAP southbound. And currently, the southbound protocol plugin is supported, but the NetVirt piece to drive that via OpenStack is not there yet. It's a work in progress. And that's kind of, if we go on to the next slide, one of the main motivations for this work is what we started looking at. How can we when we've been looking at this one southbound kind of device, how do we add a new device? And when we started looking at it, it would require reusing reusing a lot of the same functionality that already existed, but there really wasn't a good way to do that, to break it up. So what we wanted to do to support this, the hardware gateway, was to break out some of the common functionality into reusable pieces, and then just isolate the device-specific functionality into their own modules. So, and then thinking a little more broadly, we wanted to do this for the hardware VTAP, but there's no reason that it would necessarily stop there. So we want to do it in such a way that it's easy to add new southbound devices, potentially add different northbound APIs. So we do OpenStack. We probably want to look at some container networking, possibly integration with the network intent. Been talking about integration with VPN service. So I want to do it in a way that's modular. If we're going to be breaking NetVirt out into a separate project, we also want to have a proper interface for NetVirt so that we can support these new applications. And as long as we're doing all this, we want to try to do it in a way that it makes it more scalable. So I just have a slide in here to talk a little bit about just the hardware gateway pieces that we're looking at initially, and the shared functionality. And it was apparent that a lot of the things that had to be done were the same from at least a high level, and just the way in which you do it is different. And so just looking at the layer 2 use case, which is primarily what's happening on the hardware VTAP, that when when you have a new port with a new MAC added to an OVS switch, you have to, on the OVS, Open vSwitch, you have to add the flows for that, the local flows for that to handle that MAC address. You have to go around to all the other OVS switches and add remote flows to direct the traffic back to the switch where it exists. You might have to add some tunnels. And if you have layer 2 gateways, you also have to go out and program all those remote layer 2 gateways to direct traffic back to the OVS switch. But you do it a little differently, because now we're using, rather than OpenFlow, you're using OVSDB to program the remote MACs table. And then it's pretty much the same thing on the hardware gateway. If you learn about a new MAC, that switch, that hardware device is going to add information about that MAC that it just learned to the local forwarding table, report the information up to, via OVSDB, up to the controller, which would then go around and program all the other hardware gateways with the remote MAC table, and then all of the other OVS switches. So there's a certain level of functionality that's the same. So when looking at that, as I was mentioning before, we want to support different types of devices. There's the, in addition to the OVS switches and hardware gateways, there's some talks going on, maybe right now, about VPP and FIDO. We've looked at ways to integrate potentially with OVN. There could be other southbound devices to integrate with. We want to be able to also, as we during the last session, we talked about generic network functions. Have a support for developing different pieces of functionality independently and making it more modular, so it's easier to add new functionality to what exists. So I think I got ahead of myself a little bit, covered some of these areas, but what we're moving towards is a core piece of functionality, a centralized model, and different renderers for the different types of northbound interfaces and the southbound devices. So just looking at these two, the hardware gateway and the OVS switches, we're working on building a centralized NetVirt model, so a network model that describes what from the northbound side, what is required, so what Neutron is asking us to do, and then also information about the southbound devices, so physical devices, what's there, what the network addresses are, all of the information that's needed to build the configuration for the southbound device would be contained in this model. So this is at a reasonably high level. And then each individual type of renderer, one for the, in this case, the OVS switch, would have a way of building its flows and configuration. And the VTEP hardware gateway would have its knowledge about how to render that information onto its device and isolate that from the generic functions. So as it's shown here, this would be based on a centralized MDSAL model. This NetVirt renderer, and now this is, before we had this, showed that one block that's NetVirt, this is taking that and kind of splitting it out into these different pieces around this central model. So the NetVirt would take and translate back. The NetVirt Neutron renderer would translate between Neutron into our model, and the renderers would do their respective things. Yeah. Yeah. And I actually had a slide. So it's very similar to the OVN model. I think there are a few differences that will. So it's not exactly the same, but I actually looked a lot at the OVN model in working this out. So yeah, there's a northbound. There's information from the northbound that describes the desired configuration, and then based on information, I was just going to get into the point that each renderer is also responsible for writing information into that model, because the OVS might know information. For example, a new port was just added to an OVS switch, and that we were told about the logical port information from Neutron, but we don't know where it is yet. And so the renderer would learn about it from its local device and write that into the network model. At that point, all of the different renderers would have enough information now to go and program their devices. So yeah, very much like OVN in that respect. The thought is that each renderer type can handle one or more devices. You can have, because we're based on this MDSAL model within a cluster, you can have renderers on different nodes in the cluster. Each of them may be handling some subset of the devices. So let's say you can have a third. Let's say if you have 3 controllers, you could have each OVS renderer on the node handle a third of the devices to distribute the load. There's also the potential for, there's another session going on about honeycomb. There's the potential to take this renderer and using a honeycomb-like model, or honeycomb itself, put the renderer functionality out on the node and further distribute the functionality.
So just one question. Do the hardware beta schematically separated even though they use OVSDB protocol here? So are the schema objects so different? Is the reason why there's such?
Yeah, they use different schemas. So they're completely different.
Okay.
Other than they both use the OVSDB protocol.
So to integrate with OpenStack, would that OTL plugin for OpenStack work with all this?
Yes. So because on OpenDaylight, we're actually driving this off of the Neutron MDSAL model. It's there's no change. It'll work with you're asking about the new OpenDaylight? Yeah, the new plugins. Yeah, so we would still use that same plugin. I mean, you could say, you could write a separate plugin for this and talk directly to the NetVirt model. We're not planning to do that right now, but that would certainly be possible. Yeah, so I think what we'll need is a well-defined Yang model for the device that describes everything that's needed by that device to program it. So it's still going to probably down at the honeycomb agent. So hypothetically, if we're doing that, the honeycomb agent would probably still talk to the OVS switch using OVSDB and OpenFlow, but you would talk. I think the advantage of doing that is that OpenFlow in particular is pretty low-level language, and you could represent the requirements at a higher level using the Yang and talk over netconf down to the agent, which could then actually program the flows. So you might download basically a forwarding table over to the honeycomb agent, and then the honeycomb agent would take that forwarding table and translate that into OpenFlow rules.
Basically, this renderer then will be called the honeycomb agent. So is doing everything. It's configuring the OVS device, creating kernel, then installing a flow
Yeah.
right? In case of Honeycomb, it will just say create this configuration. Configuration will be decided by later. How to? It will say just create nothing, but it will do all the configuration for you. Right? That high level detail is passed to the agent,
Yeah.
Honeycomb agent, and that can do the configuration.
And I think what you end up with is like a real thin renderer up here, and then most of the guts of this is going to be down here on the node.
But there will be a requirement per device model, which is not.
Yeah, per device model. Yes.
Yeah, for compute node, basically, wherever you are OVS model. So that's where the Honeycomb, the more inherent models that requirement comes from inherent modeling of how Honeycomb actually going to work. Right? So it's like a neutron agent, right? We use to run like open vSwitch agent to run all the compute nodes, and it actually used to do the configuration. Honeycomb is probably the same line, where you don't really go to centralized controller to do all this. They just send the high level abstraction down to the switch, and it actually do the configuration local to the compute node.
The problem is coming out with that abstraction.
That's the challenge
Abstraction is always
is in all of this. Yeah, so still some work involved there, and we're not actually currently working on the Honeycomb agent. So I mean, if anybody's interested in it, I'd be glad to work with you. And it's at some point, I'd like to be able to do that.
How would it work with the multi-controller? I mean, you're talking about a multi-controller, each controller being a renderer of something else?
So
yeah, so clustering perspective, these open vSwitch renderer and the hardware gateway renderer probably is not going to change. It's like, or you can say, these are just, you need to select that one of them is going to configure this, right? So it's just like all of these boxes, blue boxes is still a network, right? They all kind of will, logically is the application, right? Although they are divided by the work they are doing, right? So you need to select which network is going to be your master and is going to do all this stuff, right? From a clustering perspective, is not much change here.
what I was thinking on the clustering, let's say we just had OVS switches, and let's say you had 3 nodes and 9 OVS switches. You could divide those OVS switches up in where you have an instance of the Open vSwitch renderer running on each cluster node, but it would be responsible for its 3 switches. And all of the information needed is advertised via this MDSAL model, so they all have the same information and can program their switches. In the Honeycomb model and clustering, I'm not sure. I haven't really not sure how that works, but it's probably pretty similar though, probably.
Pretty much you are saying you can use in the Honeycomb model.
Yeah.
But this design is not going in that direction.
Yeah.
But it's pretty open. You can even talk.
Yeah. Anything else?
I think I meant ask again. You're proposing a way to make this work on multiple controllers without clustering?
No, with clustering.
Yeah, this requires clustering, and then there's
It doesn't require clustering. It could work on a single controller. But if you did have a cluster, it allows you to distribute the workload across the clusters.
This design, the changes we are doing here is probably is basically to handle other use case scenarios. We want to make it more modular. We want to make it more scalable. And OpenStack is one use case, but we want to make it open enough so that it can interact with other systems as well. So the whole concept is same. The way network is working and the kind of clustering is going to work, that is same. It's just that the pieces which we have in a network, we are organizing in a way people can, extend it for their own solution. They can, put more features into it, and it's going to be easy for them. So it's just a re-architecture of the network component itself.
but each renderer would act like a different chart.
Sorry?
Connecting to the clustering terminology, each renderer would be like a separate chart.
Is sharding, anyway, the first thing is here, the clustering, the way clustering is implemented in network, they don't really go at a sharding. It's shard agnostic, master, owner, that is totally agnostic, right? It has its own master safe and ownership concept internally. It does not really care whether it's the same shard or a different shard. We don't really care from that perspective. We just, from a clustering perspective, we just see that there will be for this render is going to run in 3 instances. Okay, how those renders actually, work together to make it a cluster. That's the thing which we take care of.
So just back to some of what Anil was saying, I think what we, these pieces, this Open vSwitch renderer functionality and this NetVirt neutron renderer functionality and the NetVirt functions or services, and I haven't really come up with a name yet, but that maps these things. This is all part of the existing NetVirt right now. All that functionality is there, and the idea is to break it apart via a well-defined API, which is the model, so that we can then, in addition to the existing functionality, we can start plugging in new pieces of functionality. And this is just another picture of basically the same thing, but showing the goal of making it even more flexible than just supporting the layer 2 gateway, but other types of southbounds, other types of northbound APIs. And a lot of the work is to go into building this model. I did actually, when in kind of coming up with a draft model, did look at the OVN schema, northbound database and southbound database, and it's the initial focus. We have an initial model that we've put together that is really focused mainly on the layer 2 gateway hardware VTEP use case. So to integrate those two, and then based on that, we're planning to extend it for the rest of the models. And it's it's built a lot around this port, and also this is recently become learned about the network, the generic network function work, and the interface manager work, and so I'm going to spend some time to figure out how to integrate that in with this model so that we can better be able to do the application coexistence and take advantage of VPN services from within NetVirt. So that's still some stuff we need to look at. So that came kind of after this. But it is built around a lot of it is around the port. So information about the layer 2 networks and logical ports would come down from Neutron, but you don't have, based on that, you don't have enough to go ahead and program devices. You need to learn about the physical, the presence of the physical devices, and then so each device would have information about how do you reach that device over the network, IP address, encapsulation type, and then based on the learning about a new port being added, the renderer would update this the port to describe, to indicate what device it lives on, and within that device which device locator. So even within a single device, you might have multiple VTEPs, for example. In the OVS case, it tends to be one, but on the hardware gateway, you can have multiple. But once you know the logical configuration, the physical configuration, then you have enough information to go off and build the flows. There's a set of Yang files that has recently been committed to the OVSDB NetVirt project that has more details on how all this fits together, but these different pieces are represented there. Any questions on this before we move on?
Yeah. So there's a current model that gets updated through the northbound. And
Yeah.
we're talking about a separate model, and there's basically going to be logic to sort of fill in the data on this thing,
Right.
get in from the data in the existing.
Right. Yeah, so we'll map, and some of that will be, there'll be some similarities, but it doesn't contain enough information. And so it'll have the high level configuration, and then we'll fill in the rest. And then it also, I see the services as kind of helper functions that will help basically build the forwarding tables for the renderers. So provide a high level abstraction, kind of logical flows, if you will, but more I'm thinking more in terms of forwarding tables that could then be implemented down below. So one of the things also in going through this was looking at how to handle a couple. These are just some ideas that put together on handling multi-segment networks and more generic topologies. So right now within NetVirt, we pretty much assume a single segment. So everything is reachable for every switch that's controlled within the NetVirt domain is reachable from every other switch, typically over a VXLAN tunnel, but it's also support GRE tunnels and VLANs. But it's single segment. Even if, for example, one of these devices happens to be a layer 2 gateway, this would be a physical server. It would still be, you would still have a VXLAN tunnel that goes all the way to the gateway, and the gateway does the VLAN mapping. Considering another topology that comes up a lot is the topology to have a centralized VXLAN segment from the Thapar rack switches and in an IP domain with equal cost multipath, but then running VLAN from the servers up to that Thapar rack switch. And this just is thinking through some of this, you could, it requires some level of routing, and it depends on how flexible you allow this topology to be. But in a fairly, if you look at a fairly simple hub and spoke where you constrain it to the central segment, hub segment, and then leafs, it's pretty reasonable. There would be some work that's needed that doesn't exist today, and so that would figure out how to say, so if I know about, I learn about an endpoint that's over here on server 6, and I need to get to it from server 1. We need to know this switch needs to know I need to forward over a particular VLAN out that port to this hardware gateway. The hardware gateway would need to get programmed to say, okay, to get to that endpoint, now I need to go. It's really out here, but I need to go to that, this Thapar rack switch that's implementing the hardware VTIP schema. So it would stick it on a tunnel that would get it over here, and then this device would need to know what VLAN to map it to send it out. And all that's doable with our current OpenFlow and schemas, but we just don't have the control protocols currently in OpenDaylight to do that. So this is another use case that we want to make sure we cover in this model. Then thinking beyond that, there's more, arbitrary types of mappings. Maybe I don't want to go too crazy, but I want to have multiple uplinks, or maybe I just don't. We can have any kind of arbitrary segments. I just had thrown these out there just for consideration as we look at this model. Probably is not going to be the top priority to solve all these purely arbitrary use cases. The main one we want to do is to go. Initially we got this flat, single segment, and then to move to this the use case with the VLANs and the central core.
For scaling, you want to support multiple hubs connected right now.
Yeah, and then we also want to. I think that I don't know how well if that ties in with the VPN service work or not. But we definitely, one thing that's not up here that we've talked about is the interconnection of these clouds via VPN services over, so between inter data center or inter cloud services.
The one other assumption would be this would be like the one open stack instance with one OpenDaylight controller.
Yeah.
So pretty much that's a scope in which you would
Yeah.
So do you want to support for hierarchical port binding on Vishnoi?
Support for what?
Hierarchical port binding.
Hierarchical port binding.
You don't always have a framework to assign a segment ID in a hierarchical stack. So right now, OpenDaylight driver can support it. Yes.
So one, so I think the interface manager represents a set of hierarchical port bindings, where OpenStack I think is so far doesn't support that. But one use case that we do want to support is the one that at least in the short term is a container use case where you have containers inside of a VM, and you have the container ports identified by VLAN IDs, and on top of a single, say, tap port, and we need to be able to distinguish each of those VLANs as logical ports and handle, so we can avoid, one of the problems is that you end up with multiple tunnel encapsulations in that case, and we want to make sure that we only have one, or at least support that. What is there a particular use case you're thinking of?
This model is the same thing you have in OpenStack calls it as hierarchical port binding. Don't know why. but
Okay.
that's what they call it. So I think if we support this, your question is really that configuration can be leveraged here.
Yeah. Yeah, but right now, NetVirt would get some support. Yes.
Yep.
So how is that related to Neutron? With this type of fabric configuration is methodology. The Neutron is for one level higher. Right?
My understanding is that in Liberty or one of those Liberty or Flow, essentially you can configure VLAN from the server to the leaf switch, and from the leaf switch you can have VXLAN. And that feature is called as hierarchical port binding. So the same model as what I'm. So which component do you expect to manage those segments? So OpenDaylight to management to Thapar management.
Which component would manage those segments? So I think that NetVirt would manage the. So NetVirt would need to be told about the segments from somewhere. OpenStack. OpenStack does have the model of multiple segments. Different. You can have different ML2 drivers managing different segments. So I'm not sure exactly how the OpenStack would talk to OpenDaylight to set this up, but NetVirt would need to be told about the segments, and then based on the segments and the connectivity info, and then understanding where devices are. On this one, understanding where devices are connected in could set the configure the logical flows to make everybody be able to talk to each other. One other thing for anybody that's interested in looking at this, find my mouse. Where is it? Okay. Let me come over there. Oops. So anybody interested in looking at the Yang models or the code that's going into this, there's a basic framework in place in addition to the models. So it's within the OVSDB directory. There's a NetVirt directory, and the API contains the Yang models, and then there's a renderers directory that contains the code for the renderers. Right now, the only thing that's there is the hardware gateway, but pretty soon, we're going to be working on filling in the rest of it. So that's all I have for today. Any other questions?
So this hardware gateway, if any particular vendor has implemented in a slightly different fashion, how do we?
So what we're actually looking, reaching out to the hardware vendors to try to get we have some questions that, Daya has been putting together, has some questions put together on the way things work. But I'm not sure exactly what the question you're asking, but we're trying to validate what there's already implementation for that hardware VTEP southbound, and it assumes a certain implementation.
The schema is not really complex. That's what. For example, a particular switch may maybe 95%.
Yeah.
That conforms to the schema, but maybe slightly different. Is there any scope for an end user to giving such devices to customize or play with it nicely without really making a code change? Is there such scope at the northbound level so that if there is some kind of idiosyncrasy involved with the device, which is not 100% conformed with schema, to play with? That's the other way of asking the question.
So there's
Yeah.
two parts to that. Right? One is the schema itself.
Yeah.
The tables themselves are placed in as a plugin layer. You're safe because the plugin basically has a Yang model for the schema, and it does the configuration and monitor operations for the tables. Then there is the business logic, which is all sort of software, right? Which decides how the configuration and other configurations go into the schema. So that's probably where it might be easier to play around with different implementations. But we don't have the hooks in place to abstract it out. I mean, we have to do if else, if this, and that. That sort of logic is the, I guess.
Yeah, so I'm trying to think through it. Yeah, so probably with the schema, probably supports what you want to do, and you can access that directly through a REST API. However, once when we implement this in NetVirt, it's going to make some assumptions on if I want to set up a network, this is how I need to configure the device via the schema, and that's where we'd have to have to look at the details. And what we'd like to do is try to test with as many different hardware devices as we can, so that we can make sure that what we do works. And if we find differences, then we'll have to figure out how to deal with them. But it's going to be code within NetVirt that decides how to program them.
I think if any of these devices, if they don't conform to the standard, right,
Yeah.
it's very hard for any particular, to write a code because it can vary in any way, right? So if we start handling those things in a project, that's going to make things more tricky.
Yeah.
So that's why for southbound plugins, schemas are kind of interface. We adhere to the schema. If your device don't adhere to the schema, then we are changing code in a kind of NetVirt or any of the southbound plugin, that always goes to the game. So that's something which we handle in a open flow plugin, because then we kind of implemented 1.3. There were some switches who were supporting some of these things, but they were not supporting all of these features. And there was some way you have to trick code and all those things. But if you start doing that, all the time people come and go, and you forget to remove those tricks. Okay, and later all those things come as a surprise, and wish those you can vision those surprises come into production environment, and they're gone. So
The thing that we're trying to watch is, okay, absolutely agree with your assessment that everybody has to adhere. on the other hand, okay, I have everything working, but really cannot use it. That kind of way.
No, as far as it's a strict, you can use from a northbound side and
Yes.
plugin actually try to do the configuration, that's fine.
Yeah.
But if you want to change plugin, that's where the, from me it's a big no. Okay, but you can trick
Yeah.
something from a Yang model, you send some
That's what I-
sticky configuration,
Yeah.
and it kind of eventually go to the device and it get configured. That's, I
That's
think is
fine. That's what
totally
I-
fine.
Yeah.
That's what I-
And for this, we really encourage hardware vendors that implement this hardware VTEP schema to test with the code and just see if it works the way you expect it to work. And right now, like I said, there's the plugin, the southbound plugin, and there's actually in the documentation and on the website there's a recipe for how would you set up the device using REST calls directly, and there's even Postman files that you can load and enable you to do it, to just test at that level. And at the next level, it's going to be NetVirt is going to be doing the logic to take the more abstract configuration and actually program the devices, which is the way that it really end up used. So once that rolls out over the next, I don't know, couple months, that it'd be great to work with, try that out as well. And and if there's have to make certain assumptions because the scheme is not 100%. It's not 100% clear in all cases what you should do, but we can fix those.
And how do we route from, the L2 gateway? Because that's our really only, we've got the rest down there, basically, to drive the scheme, but L2 gateways are our only really northbound interface right now.
Yep.
That we write into this one. So how are we looking at, and that's, sort of your question, that's coming from the OpenStack, that's kind of our only northbound one right now. There's not really, that's the only one driving us right now. Wouldn't all the vendor stuff be in there? That's how we're kind of driving it.
Yeah, we want to look at also adding, ironic support. Because the ironic synchron integration is coming up with some models there. But that only applies for bare metal, and we want to, as a vendor, we want to support SRI ports as well. SRI. There's no good way to translate some of the geographical information of a compute node to the top of red switch for SRI. For ironic, they've done some tricks in there. But once those things fall into place in Neutron, you could translate, But yeah, those need to be driven a little bit in the OpenStack community before it becomes
Anything else? All right, thank you.